I will start dbfarm1 and then I will log in to VOC database as administrator. My password is MonetDB. And now I want to remind you that in one of the previous blog posts, inside of this one, we have talked about system table sys.statistics. This system table has statistics for all of our tables from the database. I will now go back to terminal and I will read one row from that table. So we will read only one row to see what is table with statistics. And now I will remind you that in this previous blog post we have used analyze command to update this table. For example, to update statistics about one schema, for example sys schema, we have used analyze sys. But now I want to tell you that we can also use stored procedure. That stored procedure is sys.analyze. We just have to provide the name of a schema. So this would give the same result. Similar to that, we can use analyze to update statistics for one table. For example, for table sys.odds. But again, we can use our sysAnalyze stored procedure. We just now have to use a name of a schema and the name of a table as arguments. And we can also use analyze to update statistics for just one column, like this. Or we can again use the same stored procedure, but now we have three arguments. We have to give names for schema, table, and column. But there is also one more stored procedure that doesn't have a counterpart in the analyze command, and this is that procedure. So we can apply update of statistics for all of our tables at once. So I will now run this and then we will have to wait a little bit. And now that is everything updated, I will clean my screen. I will now read from one sample table. We can use any sample table, but I will use this system table sys.odds just because it is short. We can see that it only has 5 rows. Next, I will read from one system table that is important for this example. I will read from system table sysdump statements, and this is the result. We have one empty table, and this table only has 2 columns. And I will now run one stored procedure, and this stored procedure will reference our sample table. So this sample table is referenced here as an argument, and we will use this stored procedure to read data from this sample table, and then we will place that data inside of this system table. So let's do that. I will now read from this dump statement system table, and this would be the result. And here we can see all of the records from our sample table, and we also have copy into statement that can take those records and it can place them in the table that has name sys.odds. So this would be the result. This first column is just order column. So we have 1, then 2, then we would have 3 for next table and so on. And this S is for statements. We can delete from this table, so we can empty it if we want to. So we can delete everything from this table. And we can also run our stored procedure without any arguments. So we can run this sysdump table data without arguments. So this is the same as this previous call, just now we don't have arguments. In this case, we would fill our system table sysdump statements with copy into and records from all of the tables inside of this database. I will not do that because in this database I have some really big tables, but I will jump here to this blog post. I will show you this image here. So this is from the database dbfarm.db. In that database I only have 2 tables, and this will be the result for those 2 tables. We can see order here is 1, 2, 3, 4, 5, 6, and we can see the same content here. I will now go back and I will clean my screen. And now I first want to find what table has the biggest ID. And I can do that with a simple query. And this query will first find what is the maximal ID in system table sys.tables, and then it will use that number to find the row inside of the same system table sys.tables that has a table with the biggest ID. And then we will read the name of that table. So I will run this, and the result is a table with the name tabula. So this is a table that we have created the last that has the biggest ID. And now I want to read from this table. But the problem is how to read from a table for which we don't know its name in advance. Well, for that we have to use system procedure sys.eval. And I will use it in this way. I will now create one procedure of my own. So I will create this procedure, which has the name table with biggest ID. This procedure will first declare one variable, and inside of that variable, it will place the name of a table with the biggest ID. I will again use this query from here below to find that name, and I will place that name inside of this variable. And then I will use this variable to create a string select star from tabula. But how to execute a string? Well, for that we need this system procedure sys.eval. This procedure will transform this string into statement, and then it will execute this statement. So I will create this procedure of my own, and then I have to call this procedure to see how this procedure will work. And this procedure will return this table tabula. So if we use select star from tabula, we would get the same result. And I must say that this procedure sys.eval is only available to administrator. I will now clean my screen. When we delete rows in some table in Monet, Monet will not immediately delete those rows. It will just label them as deleted. And then after some time, in some convenient moment, Monet will purge those rows. But if we update or delete a lot of rows at once, then we can call this cleaning process manually. And this process is called vacuuming. So I will use sys.vacuum system procedure to clean all of the residual rows from this table voyages. And this is a schema for this table. So if I run this, I will do vacuuming of this table. We can also vacuum only one column, and for that we will use the same procedure, but now we have to provide schema name, table name, and column name. It is also possible to make vacuuming of one column regular. For that, we will again use sys.vacuum procedure, but now we will also provide the fourth argument, and this fourth argument is number of seconds. Now we have 3600 seconds. That means that this column here will be vacuumed each hour. So this will be a regular job. So I will run this, and now each hour our column will be cleaned. We can stop this schedule by using stop vacuum storage procedure, and this is how we can prevent it to happen regularly. I will now clean my screen. Each user has a right to read his own session ID. For that, he just has to run this query, and he will find out that ID of his session is 0. So this is the first session, so ID is 0. Beside that, each user can place some limits on his session. For example, if we run this procedure set a memory limit, we can limit quantity of memory that this user can use for his queries. And this is measured in megabytes, so queries of this user can only use 500 megabytes of memory. So I will run this, and now we have this limit. If we want to disable this limit, then we just have to call the same procedure, but argument has to be 0. It is also possible to set timeout for queries. For example, I will say that this user can only run queries that last 1 second or less. And for that, I will use procedure set query timeout. if some query is longer than second, then the user will get this message, query aborted due to timeout. I will go back, and we can also cancel this limitation. For that, we will again use the same procedure, just the argument will be 0. And similar to timeout for query, we can set timeout for session. For that, we will use procedure set session timeout, and I will set this timeout to 3 seconds. So I will run this, and now if we wait for 3 seconds and if we run a query, this will happen here. So we will get unexpected end of file, and we will be out of our session. But I don't want that to happen, so I will just reset this setting. I will set it to 0, and I will get the same result because this is just another statement, and I am now out of time, so I will be out of my session. I now have to log in again, so I will again use mclient MonetDB VSC. My password is MonetDB. Next, I will change optimizer for my session, and for that we can use this stored procedure, set optimizer. I will set my optimizer to minimal pipe, so I can do this, and I can find the list of all of the optimizers if I read from this system table sys.optimizers, so we can use any of these optimizers here. And if we want to go back, then we just have to provide a default pipe as our optimizer. So I will do that. So I will again call this procedure set optimizer, but with default pipe. So everything is now back. We can also limit number of threads that our queries can use. So I will limit number of threads to just 8 in this session. And if we want to remove this limit, we would call the same procedure, but the argument will be 0. I will now clean my screen. When we access to Monet, we have to use some client. Currently, I am using mclient, and each client has some properties, and we can find a list of such properties inside of this system table sys.clientinfo properties. And here we can see that for each client, we can see the name of a computer on which that client is running. We can see application to which that client is belonging. We can see its library, its process ID, and we can also provide comment. When I'm using mclient, mclient will automatically declare all of these values to Monet. We can check that if we read from system table sys.sessions. So I will read from this system table, and here we will find the name of my computer, my client, my library, my process ID, and there is no comment. But we can also change and provide these values by using stored procedure. So I will change one of these properties. I will change this client host name. I will provide it here as an argument to the value that is old server. So instead of this being used as a name for my computer, here will be old server. And we can check that. I will run this stored procedure, and then again I will read from sys.sessions, and now instead of the name of my computer, I have old server. And this is useful because each user can declare properties of his client, so the administrator can easily monitor who is accessing to Monet and what clients are being used. I will now clean my screen. We have saw how one user can control his session, but now we will see what administrator can do. For comparison, I will now open another tab, and here I will log in, but as VOC user. My password is VOC. And if I now read from system table sys.sessions, I will find only data about this session 1. So this is the session of this user, so user can only see his own session. But if I go back here to this tab where I am administrator, and if I now read from sys sessions, here I will find both sessions, session of administrator and the session of VOC user. So admin can find session ID for each user that is currently logged in into Monet. And also, this means that admin can control sessions of other users. For example, I will now change the session of VOC user. I will limit his memory usage to 100 megabytes. I will first provide ID of his session, and then I will say that his memory limit is 100 megabytes. I will also change his optimizer to sequential type by using this procedure set optimizer. Then I will set a timeout for his queries to 8 seconds. I will use procedure set query timeout. I can also set session timeout, and I will set it to 30 seconds. I will use procedure set session timeout, and this will only affect VOC user. And I can also limit number of threads. So I will set this limit so that VOC user can only use 8 threads. And of course, it is possible to stop the session of VOC user, and for that I will use sys stop session procedure, and I will log out this VOC user. So if VOC user try to run some statement, he will be immediately logged out. I will now go back and I will clean my screen. I will now quit this session, and then I will restart my database. So I will use MonetDB stop VOC, and then I will run MonetDB start VOC. After that, I will log in as administrator, and my password is MonetDB. I will now read from one system table. Now, this system table usually has more rows, but because we now restarted our database, it will only have a few rows. So I will read from system table sys.q. And inside of it, we will see a history of our queries. For example, this query here is the same as this query here. And we also have this other query that is run automatically by Monet when we started the session. So in our history, we only have 2 queries. Instead of reading from this system table, we can also use this function. This function would return the same table. Next, I will now paste 70 queries inside of this session. So what queries will I paste? Well, I will go to this web page, and here we can see a list of queries that I have prepared. So I have queries from select 1 to select 70. I will now copy that list and I will paste it inside of the terminal. So I will paste 70 queries here. We can see all of them inside of the terminal. And then I will read from that system table sys.q. I want to know how many of these queries is saved inside of this table. I will run this, and we can see that inside of this table, by default, we will save 64 queries. And then I will create a new tab inside of the terminal. I will use open tab, and here inside of this new tab, I will log in, but I will log in as a user VOC. My password is VOC. I will now run one simple query as a VOC user, and after that I will read from sys.q system table. But I will read as a VOC user, and the result will be just 3 queries. We have this query that was run the last, we have select new query, and we have this query that was run automatically by Monet when our session started. I will now go back being an admin, and I will again check how many queries do I have inside of the sys.q table. And now the result is 61. Because in total, Monet will save the last 64 queries, and we have 61 queries from admin, and we have these 3 queries for VOC user. But is it possible for admin to list all of the queries for all of the sessions? Well, for that, we have to use an argument all. So I will now read from this system table sys.q, but I will use this function, and I will provide this argument all. If I do that, I will now see all of the 64 queries, and this is because admin can see queries for all of the sessions. For example, if I only list sessions from this sysq table, we will see both the session for admin and the session for VLC user. I will now clean my screen. We saw that Monet will by default save the last 64 queries in the system table sys.q. But we can change that number, and to show you that, I will quit this session, and then I will also stop my database. So I will use MonetDB stop VSC. Because I want to change one property of a database, and that property name is nClients. So I will set nClients to 10. As we know, nClients is a property that is limiting number of clients that can connect to Monet database. But this setting will also affect how many queries will be saved inside of the system table sys.q. We will see that now, so I will change this setting, and then I will again log into VLC database. My password is MonetDB, and then I will paste again those 70 queries. So I will paste here 70 queries like this, and then I will read from system table sys.q to see how many queries do we have now inside of this table. And now we only have 10 queries because nClients will define how many queries will be saved inside of this table. We can also read from one view, and that view is environment view, and we will search inside of this view for max clients. If I run this, I will get 10. So we can read what is the value of this setting from inside of the nClient. I will now clean my screen. If we want to find out how many queries of one user is inside of the sys.q table, then we have to provide the name of that user. So we will read from this function sys.q, but we will provide as an argument the name of a user, and we would get 10 because all of my queries are belonging to administrator. When our query is inside of this table, inside of sys.q, we can see status of that query. So I will jump to this web page, and here we can see that status can be running, paused, stopping, aborted, or finished. I will now go back, and I will now create one other tab, and inside of that tab, I will log into VLC database as administrator. So administrator will have two sections. My password is MonetDB, and inside of this tab, I will check status of my query, but I will go to this first tab, and here I will run my query. And this is one special query. This is recursive CTE query. And it is special because it is using left outer join. We know that we shouldn't use left outer join inside of this recursive CTE because then our query will never end. But in this case, that is exactly what I'm trying to achieve. I want to create an infinitive query, an internal query. So I will run this, and our query will never end. I will then go to this third tab, and here I will read from sys.q table. And this will be the result. And here I will find my query. So this is my query, and my query has ID 19. So inside of this column, this is column tag, we will see ID of our query. And I will use that to find out status of my query. Currently that status is running. We can see that for some of these other query status is finished. I will now change this status, and for that I will pause my query. So I will use storage procedure sys.pause. I will paste it here. I will provide ID of my query. I will run this, and then I will check status of my query, and we will see that that status is paused. So currently my query is paused. Then I will resume this query, and for that I will use storage procedure sys.resume. So I will resume it, and again I will check status of my query, and we will see that now my query is running again. After that I will stop my query. I will use storage procedure sys.stop. So I will stop my query, and then I will check status of my query, and we will see that that status is stopping. We cannot stop my query with this stored procedure. And this is because my query is special query. This is eternal query that will never end. Instead of that, instead of using this stored procedure, I will just use Control C. And in this way, I will stop my query. After that, I will go again to this third tab, and I will again check status. And this time status will be aborted. So we see that even if we stop a query with Control C, the status will become aborted. Now, in this way, we can control our own queries, but administrator can also control queries of other users. And to show you that, I will jump to this web page. I will go down here, and here we can see that administrator will use the same stored procedure sys.post, but beside providing tag of a query, he will also provide the name of a user. So in this way, he can pause, resume, or stop queries of any user.